To calculate the angle between two lines in coordinate geometry, the formula that helps us to do that is given as tan theta to be equals to the difference between those two gradients. The maximum has to come first, followed by the least one, all divided by 1 plus the product of those two gradients, m1 times m2. If you have interest in understanding how this formula is derived, then this video is for you. Let's begin our discussion by considering a coordinate plane. Consider a coordinate plane centered at 0. Let's consider two different lines on this plane. I will consider the first one to be in green color, and I will consider the second one to be in yellow color. You notice that the angle between these two lines will be given as this region. And let's assume that angle is alpha. How can we determine alpha? Keep in mind, at the end of the day, we must end up with this. Now, there's one thing I would like to ask you. Do you know the formula that helps us to find the slope, the angle of a slope? And here's it. To calculate the angle of a slope, all you need to do is to take the tan inverse of that slope. So let's take, for instance, we want to calculate the angle of the slope of the green line. And where will be that angle? Angle of a slope are angles that have to be measured in the counterclockwise direction because they must never be negative. They are always positive values, which means for the green line, the angle of the slope will be this angle. It has to be in the counterclockwise direction. So assuming it is theta 1. Now what about the angle of the yellow line? Where would that fall to? What region would that be? Keep in mind, it has to be the space between the horizontal x-axis and that of the line itself. Should that be this region or this? What would you say? And notice that if we are considering it to be this region, angle measured in this region will be as if we are moving in the clockwise direction. And angles that are measured in the clockwise direction are meant to be negative angles. But angle of a slope has to be positive, but not any other thing else. So therefore, the angle of the slope of the yellow line has to be at this region, theta 2. Perfect. And don't forget, this is theta 1, and this is also theta 2. Let's say this is M2, and that of green is M1. Now, it turns out that if we take the tan of both sides along these two equations, we can clearly see that tan theta 1 will definitely be equals to M sub 1. Similarly, tan theta 2 will eventually be equals to M sub 2. Keep this in mind as we will later be using it as reference. So right now I can get rid of this. Now, is there any relationship between alpha, theta 1 and theta 2? What would you say? You notice that theta 2 is serving as the exterior angle of this triangle, as you can clearly see that the intersection of the two lines, both the green one and the yellow one, and that of the horizontal x-axis has formed a triangle, which is PQR, and the exterior angle of that triangle PQR, we know that according to the properties of exterior angle, it has to be equals to the sum of the two opposite interior angles, which implies that theta 2 must be equals to theta 1 plus alpha. Perfect. This is the theta 2. Now our main goal is to solve for alpha. So what I will do is to subtract theta 1 from both sides. Then I can have theta 2 minus theta 1 to be equals to theta 1 plus alpha minus theta 1. Now we can clearly see that this can get rid of each other, and we can have alpha to be indeed equals to theta 2 minus theta 1. Perfect. So now, at this point, what I would like to do is to take the tan function of both sides of this equation. So what would that be if we do that? And that will result in this. Let me lift up this anyway. I hope you have written that. So taking the tan of both sides, I can clearly have tan alpha to be equals to tan theta 2 minus theta 1. Now, according to some of the trigonometric identity, the tan of the difference of two angles is given as this. It's given as the tan of the first one, which is tan of theta 2, minus the tan of the second one, which is tan theta 1, all divided by 1 plus the product of the two angles relative with the tan function. That's tan theta 2 multiplied by tan theta 1. Perfect. Now, we can clearly see that at this point we can substitute, since we know that tan theta 2 is the same as m2 and tan theta 1 is the same as m1. So therefore, I can clearly have tan alpha to be given as tan theta 2. I will replace that with m sub 2, and that will be m2 minus tan theta 1. I will replace that with m1 plus m sub 1. Then everything will be divided by 1 plus the product of the two gradients, which is m1 and m2. And that will definitely become m1, m2 times m1. And this is how the formula is derived. You can clearly see that that corresponds to this. Don't be carried away by the theta I used in the first place. It's still the same thing. Now, some of you might be wondering, probably you are familiar with the formula that consists of the absolute value. Well, what I would suggest is that putting the absolute value or not putting it is irrelevant. It doesn't really matters. What you just need to keep in mind is that let the gradient that has the highest value to come first, then followed by the gradient that has the lowest value, so that you won't eventually have a negative angles. Okay, we must always have a positive angles, and I hope that will help. Hopefully, you find this content helpful. If you haven't subscribed, please do well to subscribe to my channel. Thanks for watching. See you guys in the next video. Bye for now.